So in this lecture, we are going to learn about regular expression to NFA conversion. We'll see examples. So first is R is equal to A. So we'll see how do we convert this regular expression into NFA. So on getting A as the input symbol, you move from one state to the other. So here we'll be moving from start state to final state on getting A as the input. So on getting A as the input, we move from one state to the other. So this is the diagram for NFA for moving from one state to the other on getting A as the input. And we number it 0 and 1. Then next is a regular expression. Suppose it is A plus B. So in the previous case, what does it indicate? That on getting A as the input, you need to reach the final state from a particular state. That is start state in this case. Second example is R is equal to A plus B. Here you will reach the final state from either A or B. So A plus B indicates A or B. So you start with a state. Either you will go from start state to final state through A or through B. So in this case, we get two options. So this is the first option on getting A as the input. So here we write epsilon and here epsilon. Other cases, we move through B. So we get B as the input and then we move through this and we have epsilon. So the concatenation rule, epsilon dot A dot epsilon is nothing but A. So you move from 0. So this is the start state, 1, 2. Then we number it in this way, 3, 4, and at last the final state, which is 5. So either you can go from 0 to 5 through A or through B. So this is the second example. So such regular expressions we can get. Then we have third example, R is equal to A dot B. So A dot B, we are starting from A. A dot B is nothing but AB. So first we'll get A and then we get B. There is no option here. Here we want both A and B, then only we can reach the final state. So here it is 0, 1, and then 2. Then only we can reach the final state. R is equal to A dot B means we require both A and B. First A and then B, then only we can go to the final state. Then next example is fourth one is R is equal to A star. So A star means what? If we remember, L of R is equal to, when we have given A star, we can have epsilon, we can have A, we can have double A, and so on. So these are the contents of this language. We can have a string from epsilon till infinity. So we have to draw a NFA which can take care of all these strings. Here in the previous example, we have AB. So using A and B, we should reach the final state. Here, either A or B. In second example, we should reach the final state. First example, single A, we should reach the final state. So A star. So this is a rule that we'll be using. So directly we don't write A. We write like this. We have A in between. There is an epsilon before and after. So we have epsilon here, epsilon here. One is above and one is below. So this is the NFA. Then we number it 0, 1, 2, and 3. So how does it work? Suppose we want epsilon. So we can reach through this particular transition from 0 to 3 directly on for getting epsilon. Suppose we want A. So we can go 0 to 1, 1 to 2, 2 to 3. So that will give us A. Suppose we want AA. So we can go 0 to 1, 1 to 2. You'll get first A. Again 2 to 1, then 1 to 2, you'll get two A's, and then we can go to the final state. So in this way, it will cover all the strings of A star that will be produced by A star. So these four are very important. Using this, we can construct any string. So either it can be a single value, we can have or, we can have concatenation, we can have A star or A plus B the whole star, something like that can be another example. So we'll see more examples through which it will be more clear. So next example, this is very important. R is equal to A plus B the whole star. So we need to combine the previous two problems solution so that we can get the final answer. So we start from start state. So first we'll write A plus B. We'll show how A plus B was done. So first either you go through A or through B, and then we reach the final state. So this is for A plus B. So this we have already learned. Now if you see the previous example, your A plus B is this part. Now we want an epsilon before and after, and there will be one from that particular next state to, so that we can come back, and one to skip. So same thing we'll have to apply here. So what we do is, so this was A plus B. So one epsilon after, one epsilon before, then this will be our start state. One for coming back. So we want to come back. So for that we will have one epsilon and one for skipping all the contents. So it can take care of epsilon. Then we start numbering. So this will be 0, 1, 2, 3, 4, 5, then 6 and 7. This numbering is very important. So we take one particular route, start from the start state, number it as 0, and then we take a route, then the other route, and then we go ahead. So final state is 7. So you should check once you've drawn the NFA also. So epsilon, is it taking care of epsilon? Yes. From 0 to 7, we can directly reach on epsilon. Suppose we want single A. So we'll move from 0, 1, 2, 3, 6, and 7. So we can move from here and reach 7. Suppose we want single B. That is also possible. We can move from 0, 1, 4, 5, 6, and 7. Suppose we want AB. So we can move 0, 1, 2, 3, 6, come back to 1, then 4, 5, 6, and then to 7. So we'll get AB as a string. So it will take care of all the strings that can be generated. So this is very important. This we will require when we are doing the conversions and all. Another example we'll take, suppose the next example is R is equal to A star plus B star. In previous case, it was A plus B the whole star. So here A star is separate, B star is separate. So how will it come? So first we'll start for A. So this is A. So one epsilon after A, one epsilon before A, then one above and one below for skipping all the states. So this is another epsilon. So this is A star. Then we'll do it for B as well. B star. So first comes B, then one epsilon after B, one epsilon before B. Then there is a transition which will skip B. So this is A star and B star. Now we have to combine. So we'll require two more states for combining. So we have a start state here. Then we start numbering 0, 1, 2, 3, 4. Then we come back here 5, 6, 7, 8, 9, and this is the final state. So we move from 0 to 1. Suppose we have A. So it can move from 0 to 1, 2, 3, 4, and directly 9. Suppose it is B, 0, 5, 6, 7, 8, 9. Suppose we have A, B, B, B. So we can move on the upper part to get all the A's and lower part to get all the B's. I hope so it is clear.